Hello, CodeMash. How's everyone doing today? There's still some people trickling in, so I'm gonna start a little soft. Before I get into this, I got a lot of stuff to go over with you today that's really exciting. It's really awesome. But before I do, I kind of want to tell you why I decided to talk about Kubernetes. I've been programming for a little over 25 years, and I've seen the industry as a whole do a lot of pretty cool stuff. However, I notice more and more we're all trying to get that extra 1% of efficiency. We're trying to get that little gain, and we're doing stuff like we're getting new frameworks, we're doing new languages, we're doing a lot of really high energy stuff just to get a relative amount of efficiency. What I like about Kubernetes is it's relatively low workload or low output to gain a tremendous amount of efficiency. And I'm talking, when I say this, I don't mean just an efficiency for a developer. I mean efficiencies across the entire organization, from your development all the way through to your business people, your DevOps people, everything. I really like Kubernetes. The few times that I have set up systems using Kubernetes, it was very easy and worked very well. So that's why I'm talking about Kubernetes. So you'll notice up here there's a big QR code and there's a link. That is, if you hit that link, you get these slides. On these slides, you're going to see a lot of content and several links. So it may be a good idea for you to get that now if you haven't already. So that's all the time I'm giving you. I hope you've got it by now. Before I really get in and get going, I know the first burning question on everybody's mind is, who is this guy? He looks like he mugged someone to get in here. You know, I think my favorite thing that's ever been said to me after a talk was somebody come up and they were actually being very sincere and they said, wow, I had no idea you were smart. It gets better. And I said, well, thank you, I think. And then they said, so are you just one of those people who are really smart? You've just made a lot of bad decisions in your life? And I said, again, I'm sure there's a compliment in there somewhere, thank you. But no, my name is Dale Alleshouse. You can get me on Twitter at HumpbackFreak. You can go out and check out my blog, hideoushumpbackfreak.com. Yes, that is my name for obvious reasons. And you can get me on GitHub at github.com/Dale Alleshouse. I work at Carnegie Mellon's Software Engineering Institute, where we do computer science research. Now, the Software Engineering Institute is a federally funded research and development center, meaning we get money from the Department of Defense. Therefore, I am required to tell everyone here that this work does not necessarily correlate with the views of the university. This is my own opinions, my own work, and my own things. Everybody got it? Legal disclaimer out of the way. So with no further ado, let's go over an agenda. What are we going to do today? First, we're going to define what Kubernetes is. Has anyone in here ever worked with Kubernetes? A few people? Okay. Then we're going to look at what are the goals of Kubernetes. What exactly does Kubernetes hope to accomplish? And we're going to look at the basic architecture of Kubernetes, how it accomplishes what it plans to accomplish. And then we're going to look at an awesome Kubernetes demo. Everyone clap. Woohoo, yeah. You can see it up here, what we're going to go over. I actually built a Kubernetes cluster out of Raspberry Pis up here. We'll go over that and how it works and see some pretty cool stuff. And then once you get all this exciting new knowledge and you're all psyched up, you're ready to go, I'm going to tell you what now. What can you do to start using Kubernetes and use it in your organization? So, first off, what is Kubernetes? The first thing about Kubernetes that confused me is I always saw this K8S. And I thought, how the heck is Kubernetes abbreviated K8S? That doesn't make any sense. Well, apparently, it's K 8 letters, and then the letter S. This is very common in the military. They do this a lot. It's a common abbreviation. I didn't know that, but hopefully that saves you guys some of the confusion that I had when I first started looking at Kubernetes, so you don't have to think that out. Kubernetes is Greek for ship's captain. I think it's literally translated as helmsman. If everyone's familiar with Docker, I hope. Yep. I'm just pretending everyone's shaking their head yes at this point. So going along with the nautical theme of Docker, if you got shipping containers, Kubernetes allows you to manage those containers. It's the ship that these containers are riding on. So that's all you need to know. That's it. All right. Okay, so what it is, it's an open source container management system built by Google. A little known fact, or maybe not so little known, is the original commits into the Linux kernel that made containers possible was by engineers at Google. Containerization, a lot of people think is pretty new, but Google's been doing this going back over a decade. It's often touted on the internet that Google spins up more than 1 billion containers in a day. Google was using containers long before Docker came along. Docker came along and did the amazing job of wrapping up containers and made them easy to use. You can actually build a container completely by yourself without Docker if you got some pretty strong command line kung fu. But most people don't want to do that. So inside of Google, they had this project called Borg and Omega, and that is what Google uses to manage these containers. It's really easy to spin up a container. It gets a little difficult when you think about how am I going to get this container to talk to a bunch of other containers that come and go. How do I figure out how to schedule a container somewhere? If I have 50 machines and I want to spin up a container, where do I put it? This is what Borg and Omega, this was their answer to it. After the extreme success of Docker, Google decided to open source something based off of Borg and Omega. It's not their exact system, but it's based off of it, and then they're taking those ideas and incorporating them back into Borg and Omega. Now, I've heard it speculated, not from anyone at Google, but I've heard it speculated that eventually Kubernetes will replace Borg internally at Google, but I don't know that to be true. It originally hit GitHub in June of 2014. The 1.0 release was in July of 2015. So we're about 2.5 years in Google, right? Or, sorry, 2.5 years since it went live. We're currently in release 1.9, meaning they're doing a release about every quarter. I think that's their cadence that they shoot for. The most amazing thing about this, though, is that Kubernetes, in this short amount of time, has completely decimated all of their competition, being places like Cloud Foundries, Mesos, Docker Swarm, all of these people. In the container management industry, I believe at last count, they had over 75% of the market share. As a matter of fact, Docker Swarm, their biggest competitor, finally conceded about how awesome Kubernetes is. The latest version of Docker Enterprise comes bundled with Kubernetes. Now, no one gets scared if you use Docker Swarm. Docker Swarm's not going away. However, Kubernetes is bundled in as a default option with Docker. That's pretty good for us open source project that's only been around 2.5 years, right? Everybody say yes. That's awesome. All right. So that's what Kubernetes is. Let's talk about the goals. What does Kubernetes promise to do for you? What's their goals? They want to take you from your most granular form of deployment, from being a VM to being a container. How many people here have used something like Vagrant? Okay, almost everyone. So great, this analogy will land great. Instead of using Vagrant and making your most, the smallest thing you can deploy be an entire VM, they want the smallest thing you can deploy for an application to be a container. Everyone knows containers are much smaller and they're much more flexible. Well, I wouldn't say more flexible, but you get the point. They also plan to be portable. You can run Kubernetes literally wherever you want to. You can run it on Windows. You can run it on FreeBSD. You can run it on Linux. You can build your own little Raspberry Pi cluster and run it in your bedroom if that's what you choose to do. It's very portable. It's general purpose. One of the things I've noticed from using other container management systems in the past is that they give you the ability to run a stateless app. That's what containers are pretty much optimized for. However, Kubernetes says that's not enough. I want to give you the ability to run a stateful app, meaning I can run a database in a container. They give you the ability to hook into permanent storage using Kubernetes, running a database in a container. It actually works pretty good. I think that alone is a reason to look at Kubernetes. But they also let you, and that's not all. It lets you do batch jobs, cron jobs, it'll slice, it'll dice. Whatever it is that you want to do with Kubernetes, they're going to let you do it. It's also very flexible, meaning you can use as much or as little of Kubernetes that you want. Consume it a la carte. It's also very extensible. You don't like a part of Kubernetes, extend it. It's very easy to drop new functionality in there. When we get to the architecture section, I'll tell you why. It's also very automatable. All of the management for Kubernetes is done via a REST API. How many people in here think you're capable of writing a REST client? You can automate Kubernetes. But it's even easier than that because every single one of the major languages, including C#, F#, Java, JavaScript, Go, they all have a port for that's a wrapper around that REST API. Makes it really easy. In the demo today, we're going to use a command line interface called kubectl, or I usually call it kubectl, for managing our container. But it's just a wrapper around that REST interface, so you can do whatever it is that you want to do with it. The main goal of Kubernetes is to advance the state of the art. They want people using cloud-native, DevOps-focused mechanisms for hosting your applications. Why would they want to do that? Well, because it's awesome and it's easier. Do I need to convince anyone in here that these containerized apps that are easy to deploy are better than the old way of doing the monolithic apps? No one I need to argue with about that? Okay. They want to get you there. However, they understand that you can't just throw away your app and start over tomorrow. We have this thing, for some reason managers expect there to be some sort of return on investment on the code that they write. I know, it's crazy, but they want it. So what Kubernetes does is they give you a way to run your old monolithic applications, your old legacy applications in Kubernetes and slowly migrate them as you go. So I thought I had another point, but I apparently left it off. So that's all the goals for Kubernetes. Now let's start to look at the architecture, how Kubernetes accomplishes all of its goals. You'll see you have a master and minions. This is standard distributed computing. They didn't do anything special here. This is how pretty much this is how Zookeeper works. This is how all of them work. What's special about this is the way the services interact with each other. If you see everly, I'm not sure that's a word. Every light blue square is a service. It's a completely independent, autonomous service, meaning it's not really aware of the other services. There's two ways to write an app. Well, there's probably more than two ways. But you can make a container management system that is orchestrated, meaning you have a single thread of control that manages every step through the process. Or you can have an emergent behavior, meaning much like the cells in your body work, your cells really don't know what the other one's doing. However, the behavior of all of them together create systems behavior. Does that make sense to everyone? Good, because that's how it works. The major ones that you need to think about, if we come all the way over here, I guess it's on your left, and look at the kube scheduler, that is what, when you hand workloads to Kubernetes, that's what tells Kubernetes, that's what figures out where to run them. So if you have if you got 100 commodity servers right there, the scheduler is going to figure out where to put them. It's smart enough to know if I hand it 3 identical workloads to not put them on the same server. It's going to split them out across your cluster. And it keeps track of where the load is. So if you have one particular machine that's overloaded, it's going to route that to other places. The Kube API server, we've already talked about this. This is just the REST interface. For speaking to it, you got the controller manager. That's what actually does the work. This is your controllers. And then at the bottom down there, you have XCD. Is everyone here familiar with XCD? Okay, yeah, it's a name value store, very similar to Redis. It's a data store. Why did I think that was important to put it on there? Just to let you know that it's relatively easy to configure XCD for a highly available application. So you can make Kubernetes highly available by just scaling out your master here and scaling out XCD. XCD actually holds all of the state. And as you'll see when we get into the demo a little bit, Kubernetes has what's known as desired state and actual state. So you tell Kubernetes, this is my desired state. It will constantly check the actual state and bring, try to reconcile actual with desired. So if something fails, what happens? You're not in your desired state anymore. It'll automatically bring it back up. Things like this, but it's in a very disconnected fashion. Now, if we look at each minion in the Kubernetes cluster has to be running a few services. The first one is the kubelet. This is what the kube controller manager talks to tell each individual minion to perform an action. The next is the kube proxy. The kube proxy is very important because it does all of the routing. This is service discovery. So if I want to access X service that's running in my cluster somewhere, I don't know what box it's on, I can hit any one of these boxes and that proxy will route me to the right place. Does that make sense? You guys can smile, it's all right. And then we have cAdvisor. Has anyone used cAdvisor before? If you've used Docker a lot, that is what tells you it gets performance information inside individual containers. So it can look at inside your C groups and your processes and collect that information for you and give it to you. So you have a lot of visibility in here. And then finally, this is where your work actually makes it, is hopefully this comes back. Okay. Wow. Okay, sorry about that, guys. If you have Docker running here. Now, I show Docker up there, but Kubernetes is actually very flexible. If I don't want to run Docker, I don't have to. I can run Rocket. I can run the old containerd stuff. I can run any container management system I want. The only requisite is that you have to be able to manage containers. And then you have pods. Pods are your actual workloads. For the purposes of this demo, and for simplicity's sake, you can equate a pod with a container. They're basically the same thing. The reason it's called a pod in Kubernetes is that if you have several containers that need to run together for whatever reason, they're coupled, they have to be on the same machine all the time, and they cannot be scheduled the same way other things can, you can wrap those up in a pod, and they'll always run together. But however, for our purposes, it's just a container. So I know I've thrown a lot of information at you in a short amount of time, and I don't expect anyone to remember all that. As a matter of fact, I just said it all, and I probably forgot some. But that's where these links come in handy. The first three are white papers put out by Google. How many people just love to read white papers? Great, there's actually a couple people that do. There's probably a support group for you guys. You can probably check that out. No, but honestly, I know white papers aren't always that fun to read. However, these are very well written and they're accessible. I mean, I understood them, and look at me, okay? What's that? Yeah. Check them out. I highly recommend it. And at the bottom, you have the link to the GitHub, the Kubernetes GitHub community. There is a ton of good information out there. There's flowcharts that explain exactly how the scheduler works, everything. If you want to extend it, there's instructions for it. There's more information than you're possibly going to read. And it's all really good information. So I recommend checking that out. So who wants to see a demo? Yay! All right, I know what you're all thinking. Maybe he'll be quiet for a while. Okay, this is the demo that I'm going to show you. If you look at the bottom here, there's a link to my GitHub account that has all of this code on it. And the README file in there has every step that I did to build that cluster, as well as every command that you're going to see throughout this, as well as all this code. Everything you need to do this at home is there. The reason I'm telling you this is because I don't want anyone to flip out thinking they have to remember all of these commands or try to write them down. The purpose of the demo is to explain to you what Kubernetes can do and show you some of its functions. Don't try to memorize it, because then you'll miss the bigger point, okay? So here's basically how it works. If we go, can you guys see my pointer here? Okay, starting all the way over here, we have a standard Nginx container, and that's just serving up a HTML file. It's got a little bit of JavaScript in it. We come down here, this just represents your browser. Obviously, that's not a container that will be running in our system, but all it's going to do, your browser, you pull up this file, and it is going to make a request out to this ASP.NET Core REST API. This is a container that will be running inside of Kubernetes. This container talks to RabbitMQ and says, hey, how many items do you have in your queue? How many have you processed? Just let's chat. Give me some information. And it's going to report that back to the browser. And the browser is going to display the queue statistics. If we come all the way over here, we got a Ruby producer, and it does something really awesome. Every second, it pushes a random number on a queue. I know it's amazing, but it does. And then we have a Java consumer, and all it does is pull items off the queue, and it generates Fibonacci numbers based off of the random number it's got. So basically, we're just simulating some load on the server. Now, when you go out there and look at this code, I'm going to tell you, I do not recommend pulling that code and trying to build your system at work based on that code. I think the longest amount of time I spent on any one of them services was 20 minutes. The point here is Kubernetes, not necessarily the code inside those applications. All right, enough talk. Is everyone ready to see this work? All right, let's go. So the first thing we need to do, we look over here. I've got a fresh Kubernetes cluster right here. And here's what I did before I got here. I created this cluster. It's got 4 Raspberry Pis. I welcome anyone to come up and check it out. I use kubeadmin, which is a command line tool freely available from Google, and I ran setup on all 4 of the Pis. The whole thing took me approximately, I think, an hour and a half, and that's including burning the operating system on each one of the cards for the Pi. So it was really easy to do. If you want a really good tutorial on just setting up a Raspberry Pi cluster, this does not have anything to do with Kubernetes. Check out Scott Hanselman's blog. He's got a really nice step-by-step. And he goes into the hardware a little bit more than I do. The next thing I did is I have this router. I walked into Best Buy and I said, please give me the cheapest router you have. Carnegie Mellon gave me a $200 budget. So this is the best Kubernetes cluster you can buy for under $200. And I got just a basic router, and I assigned static IPs to each one of my 4 Raspberry Pis. Obviously, if you're doing this in a cloud environment or something, you'll have something a little bit more better than that. And then I edited my host file to give each one of these a name. I named them K8 Master and K8 Node 1 through K8 Node 3. And I put that host file both on this Windows machine, and all the demo stuff I'm going to be doing in Windows Subsystem for Linux, so I edited that host file in there too. So that's how all the networking stuff is set up. And then all of the images are hosted on my personal Docker hub account. I did go in to each one of these Pis before, and I did a Docker poll, so all of those images are local, because I really didn't want to be standing up here when the internet decided to be a little capricious and not be able to pull down a image for you. So now I'm really going to start. I know I've got you guys all ready to go a couple of times, and I pulled back, but now we're really going to start doing something. So the first thing we have to do is create our workloads, right? We saw the 5 containers. They're 5 completely disparate technologies that that are running in containers. We have to create a deployment. So I am actually going to be copying and pasting all of my commands because I'm lazy. If we go out here, this is the command we need to create a workload. We're using kube control. I already told you about that. And I'm saying run. That looks exactly like a Docker command, doesn't it? A lot of this stuff you see looks exactly like Docker commands. That's what makes it easy to remember. I'm saying, hey, I want you to use this image on my GitHub account, or GitHub, Docker Hub account, HTML-frontend 1.0. This is my Nginx image. I want you to expose a port, set a status or an environment variable, and I want you to give it labels. Labels are the way that you're able to find things in Kubernetes. So whatever label you put, you can query against those labels, and that's why they're set up in there like that. So are you guys ready? You want to see what happens? All right, let's do it. Hit enter. We just deployed that container on a Kubernetes cluster. Woohoo! Yes, it's amazing. We can now, we come out here. Oops. And I learned to type. Oh, sorry. You are correct. Okay, so we can see our containers running out there, and that's literally all we had to do to get that running. And I guess I should have stuck with my mantra of I'm going to copy and paste everything. So rather than talk through these other ones, I'm just going to copy them all. I'm going to paste them in here, one at a time. Okay, we have actually, if this was your production environment and you wanted to release services out there, that's what you do. Does everyone think they can handle that? That's not too bad, right? So now we have 5 containers running out there. we look, they're already up and running. We can see how many is available. Remember I told you about desired state and actual state. It shows you right there. And we can look at the individual pods, because a deployment, remember, can have more than one. So we can say kubectl get pods. These are the actual names of the pods running out in Kubernetes. I have no idea. Without looking, I don't know which one of those pies we've decided to put anything on. But let's take a look at this Java consumer one. See what we can do with that. If I can get it. So I can actually say kubectl execute, the same as Docker. Give me an interactive terminal into here, and I want you to run bash. I'm actually looking inside a container running in a Kubernetes cluster, regardless of the fact that I don't know what physical machine it's running on. Thank you. Come on, this is awesome. So, pretty much all of the standard Docker commands you can run. So I can say, I want to look at the logs on that particular container. And this is what log's going on right now. Apparently there's a problem, right? We have errors. There it is, it's trying to find that queue service, but it doesn't know where it's at. There's a couple things we could do. One, I could just open up that container. I could find the IP address of where my queue is running, and I could tell this Java consumer where it's at, but that stinks, right? We don't want to do that, because what happens if the queue goes down and has to be brought back up somewhere else? That IP address changes, we don't know. So what we need to do is create a durable service. A service in Kubernetes, we use the expose command. So I'm saying, hey, expose the deployment queue on these two ports, and I want you to use the name queue. So this is service discovery. I'm telling you, every time you use the name queue, route to the pods that have this in it, regardless of where they are. So the pods can change, the service always stays the same. So now that I've done that, I'll look in here, and it looks like we're actually processing Fibonacci numbers. Woohoo! It was that easy. Yeah. No, it's that kube proxy. So how many people have actually tried to network in a do like service discovery and containers and stuff like that without Kubernetes? Was it that easy? Yeah. This stuff is awesome. I get excited about it. So the thing is now that we have our internal network set up, I meant to bring a mouse, so I'm doing all this with touchpad. We need to expose some services externally, meaning that our HTML front end, this is our Nginx service. We need to be able to access that from outside the cluster, and the status API, which is our ASP.NET Core service, the HTML front end needs to be able to make a request to that from outside the cluster. In order to do that, there's two ways you can do it. The way I'm doing it right now, as you can see, I created this node port service. That is saying, hey, when you see this node or this port right here, I want you to route that to this service. Okay? And that's available outside. However, if you were doing this in your production environment, nodes or ports aren't the way to go. You're going to want to use a load balancer. It's actually really easy if you're doing this in the cloud. It's literally, instead of saying node port, you say hook me up to a load balancer, and then you get a automatic IP address and everything's beautiful. That's a little bit harder to do on my Raspberry Pi cluster, so that's what I'm going to do. So now that we've got our external networking set up, let's see if we can go out and look at the app. Wow, check that out. Okay. Come on, you guys got to admit that's awesome. I just deployed 5 different technologies that are on working across 3 different machines or 4 different machines, had no idea where they are, and I could actually do this anywhere now. And I did that in that many commands. Does everyone agree that that's probably easier than the other way? Okay. Now, you'll notice, but here's the problem I have. I don't like the way we did it. And I'll tell you why. What would happen if somebody come up and stepped on my Raspberry Pi cluster? Well, yes. But after that, I would have to recreate my entire system. And the only way I'm going to be able to do that is to remember all these commands I typed in, right? So I'm angry. I don't want to have to do that. So I'm going to say, what's that? Oops. I'm not in the right directory. I'm going to delete everything we just did, just simply because I didn't like the way we did it. Because I'm like that. All of our hard work is going away. Everything's gone. Easy come, easy go, right? So the reason I did that is because I don't want to have to remember to type all of that stuff in again. Wouldn't it be awesome if there was some way we could store all that in source control? There is. This is a YAML file for the Java consumer that we're looking at that basically describes the command that we gave it. If you look over here, I have a YAML file representing each one of those commands that we put in. And that contains all the parameters that we gave it on the command line. So now, if I want to, and this is actually dead now, nothing there. I can come over here and I can say kubectl create -f, that means file, and I'm pointing to that directory that I just created. I say kube. It just created everything again. How awesome was that, right? All of our hard work is back. I wasn't going to leave you guys hanging like that. We come back out here and it's created. Now, if you set your stuff up right, you should be able to save all these YAML files in source control, push them through your system, and do an automatic deploy just with that single create command, and everything just works. Okay? So, another big problem I see with container management systems is they don't give you a lot of visibility inside the containers. And when they do, it's something that a developer has to go in and do, right? It's really hard to figure some of that out. So, Kubernetes comes with a dashboard by default. The kubectl proxy thing is just saying, hey, I want you to proxy that dashboard back here to this machine on 127 or localhost 8001. And then you're going to need a bearer token. I'm not going to go into why you need these or what they are. However, I want to tell you that Kubernetes is absolutely serious about security. You really need to, they really want you to do it right. So they're almost going to force you to do it right. So if I come out here now to the address they gave me, go to UI. It's going to give me this dashboard. It's going to ask me for the token. I'm going to sign in. Now, this dashboard comes default with Kubernetes. It's going to give me all kinds of information. It's going to tell me usage on each one of my nodes, what's up, what's down. You can look at your deployments. You can do pretty much anything through here. You can come up and hit create. You can define a service this way instead of having to do it through your YAML file. You can drill down into individual pods and change their configuration with edit. Pretty much anything, and that comes out of the box. It's free. Anyone can use it. Comes with it. How awesome is that, right? You can clap. Come on. Come on. I shouldn't have to keep telling you guys this. Come on. We're halfway through this. So that's the dashboard. So, how many people have ever had to scale something? So let's say that we've decided that our HTML front end just isn't cutting the mustard. We need more of them. We need more instances of it running. And Kubernetes, it's literally as easy. I'm going to come out here, I'm going to say scale the deployment HTML front end. Give me 3 replicas of it. And then I'm going to come out and I'm going to say get deployments. And you can see in that short time, I asked it for 3. There's already 3 up there. There's 3 available. If I come out here, we can see the, this is the pod we were hitting. Let's hit refresh. We automatically switch to a different pod. Now, one thing is, just because of the way I have this set up and with the pie, I'm kind of stuck here. I've got, every time I refresh, it's going to keep going to the same pod. But if there were multiple people hitting this cluster, they would all be getting routed elsewhere. But we actually have 3 copies of that running load balanced in our Kubernetes cluster with that one command. Is that a little bit easier than the other way? Okay. So, but here's the problem. Did it bother anyone else that I had to figure out for myself that it was our front end that was causing the problem? That kind of sucks, right? I'm a developer. I don't have time to sit around worrying about whether my app's running or not. I have to be doing cool stuff, right? If I'm worried about my app running, I'm not writing code. So here's the thing. I want Kubernetes. Wouldn't it be awesome to say, hey, Kubernetes, you figure out where the problem is, and if you need more, scale it up. We can do that. So what we're going to do, if you look here, obviously we have a problem with this Java consumer. We're dropping a lot more items on the queue than he's picking up. Java consumer is just plain lazy. I think he may be a manager. Sorry, I didn't think any managers would be in here. I'm sorry, I guess I'll have to, I apologize. So what we're going to do, Kubernetes has this auto scale function. So what I'm going to tell Kubernetes to do, did I not get it? I tell Kubernetes, I say, hey, auto scale the deployment Java consumer. I want you to do a minimum of 1 and a maximum of 5 based on 50% CPU usage. If we go out and look at this dashboard and we look at our deployments and we look at our Java consumer, we can see that our current CPU utilization hasn't been updated yet. It will be shortly. So what it's going to do is it's going to look at the total amount of CPU that I have allocated for those pods. If that goes above 50%, it's going to stop dropping more pods in there to account for it. If we come out and we say get deployments right now, you can see that the Java consumer has still not decided to to scale up. Well, this is embarrassing. I promise by the end of the video or the demo, it will. It's you're actually, every time you spin up I'm trying to think of how to say this. It's based on what CAdvisor reports. So technically it's on the node, but they're kind of linked. You know what I mean? So if I said I've got 3 pods running on one machine, they each have 30% of the node, and one pod was using 50%, that's that much processor usage inside there. Does that make sense? Okay. If not, we can talk about it afterwards. So let's see if it's scaling up yet. It is not scaling up yet. So, well, the demo gods don't like me today. But if it had scaled up like I wanted it to, you would see the in-process number start to climb here based on the load. And I probably have some faith that I'll figure that out before the end of the demo. Well, the problem is it's not reporting, CAdvisor isn't giving me the information back. It doesn't know how much it's using. Right now, if I look in my dashboard, you can see the current CPU utilization is, I don't know. Let's refresh maybe. So it's not coming up right now. I'm not sure what's going on, but I'll figure that out later. So I guess you guys don't have to clap for that one, but if it had worked, trust me, you would be clapping right now. It was really awesome. So the other thing is Kubernetes is self-healing. Let's suppose, let's take a look here. Well, if I can actually get this to copy. I'm just grepping out for this front end. We can see what node each of those HTML front ends is running on. Let's look, if we look here, it's this MX74X, correct? Let's refresh this a few times, make sure that's the one we're getting. MK74X. Looks like MK74X is running on node 1. I need a volunteer from the audience who wants to do something absolutely nefarious. Yep, come on up. Whichever. All right. I know you've always wanted to do this in your data center, but you've never been able to. What I want you to do is come over on this side. Yeah, don't trip over that thing. That would be bad. I want you to find K8 node 1, and I want you to unplug the cable. Oh! Tell me all of you haven't wanted to do that at one time or another. Come on. That was awesome. Thank you very much. You did a perfect job. So, by all rights, our site should be dead, right? Watch, it's probably going to die now that the demo goes over. I promise you it'll reroute. If I look at our deployments, it's still showing 3 available. It is going to, as soon as it figures out, there, it changed. Whew. Thank you, demo gods. Okay, so Kubernetes was smart enough to figure out when I requested that pod again, it knew that it died, and it went ahead and spun it up on a different machine. So I still have 3 deployments running in that short amount of time. You can see, well, I have 2 now. It figured out the one is dead, and it's spinning up another one right now to account for the one that died. So without me doing anything, this was pretty much configuration free. Kubernetes automatically figures out when your pod dies and automatically restarts. How awesome is that? Yay! So you know what that means? That is one more morning that you will get to sleep past 2 a.m. Yeah, you'll need to, we'll talk about that after. I don't mean to cut you short, but I got 10 minutes and a little bit of this to go yet, but come up and talk to me because that is a really good question. Oops, I hit the wrong button. But here's the problem with it. How often is it that your app dies because a machine died? More often, it's because something went wrong. Well, not with the code, because we're developers and that doesn't happen, because it worked on our machine, right? Yeah, so obviously somebody did something wrong when we pushed this out. Wouldn't it be nice if we could monitor that and say, look at something besides that? Well, luckily we can. If you'll notice in the HTML front end, I have a liveness probe and a readiness probe. And what those do is, this one in particular is going to be looking at this health.html, and we can go out and look at it here. I want to get this pod name on my buffer here. It's returning all healthy. Obviously, you can do something a lot more complex with that. You can, it doesn't even need to be a website. It could be a bash command, whatever. And I'm saying, hey, anytime this dies, I want you to take that pod out of service and do something else with it. So what I'm going to do is I'm going to say, I want you to execute on there. Let me get the exact command so I make sure I get it right. I want you to remove that. Oh, I do? Perfect. So what I just did is I reached into this Docker container and I killed that. And I actually think it fixed it too quick for me to show. Make sure this is the right one. Refresh it. Oh no, it already changed it. Okay, so let's do this one more time. Did I not get it? Okay, now, hopefully, if I come out here, I got a 404 not found. So what it's going to do is after a couple seconds that it figures out that this is down, it is actually going to completely restart that pod. So if I say kubectl get events, and I grep that pod name out of there, what's that? Oh, yeah. Can't you just say grep? Do you really have to type it? Yeah. Okay. So if you look in here, you'll see it was scheduled, it was unhealthy, hey, I'm going to kill it. And then it said, hey, I'm going to successfully create it. If I come back out here now and refresh that, it's all healthy again. How awesome is that, right? Okay. Now, there's one more awesome thing I'm going to show you. Now that you know it can self-heal, it can do anything, right? What happens when you create an update to your app and you want to get this out in production? What's the easiest way? We want to do this during the day so no one, with no downtime, right? That's kind of a pain in the butt. Luckily, I actually had Andy here write an update to my site because I didn't like the way it looked. It looks kind of plain. So I said, hey, Andy, will you do it? And he did. He did it for me, and we're going to deploy his change. I haven't looked at it, so I don't know, but we're going to deploy his change out into our production environment, all right? So all I'm going to do is I'm going to say, hey, set the image of this deployment to HTML 2.0. Is everyone ready to see Andy's work? Okay, we're going to hit enter, and what that's going to do is it's going to go out to those pods one at a time, pull one out of service, create a new one. When the readiness probe comes back in, it's going to dump it in. So you actually get zero downtime because it's only pulling one pod out at a time, right? So let's see how he did. Andy, man. Okay. Andy, stand up. I just need you to stand up for a minute. Okay, turn around so everyone can see you. On the count of 3, I want everyone to chastise Andy, okay? 1, 2, 3. Andy, come on, man. Yeah. Okay, but we're going to cut Andy some slack, and this is why. Because we have a Kubernetes installation here, I'm not that worried about it. We don't have to go through GitHub commits, and we don't have to do all of that. All we have to do is come out here and grab this command. This is our rollout command. We're going to say kubectl rollout, undo that last deployment. Now, it's going to do the exact same thing. It's going to go out, it's going to grab one pod at a time, take it out of rotation, update it. When the liveness probe comes ready, it's going to come back. So let's go out and look. We're automatically back to our old stuff. Man, that was safe. Yeah. No thanks to Andy, but we did it, and I apologize that you all had to see that. So I don't want to upset anyone. However, that is the end of the demo. I'm sorry. Oh, yeah, I know. Did it? Awesome. There you go. It just keeps, see what happens when you undo Andy's work? Okay, that's the end of the demo. However, you guys aren't done with me yet. I promise you what now, and I'm gonna have to go through this real quick because I got like 2 minutes. Now that you're all, who's all excited about Kubernetes? All right. I want you to go out to the docs. I want you to read these. They're really good. There's a free online course from Google by Udacity. I want you to go out and take that. And if you have problems, you just don't know what to do, give me a call. Hit that QR code. That's my name, my email address, everything you need to get a hold of me. Please follow me on Twitter. I never post anything there. But you can still follow me. Also, come out and check my blog. I blog about once every 8 months, whether I need it or not. And you're welcome to consume that comment. But seriously, if you have a problem or you need something, give me a call. I'm really happy to help. Now, I need you guys to do something for me. Thank you so much. You've been a great crowd, and I appreciate the enthusiasm. But everyone remember, on the CodeMash app, there is a place to do surveys. At the end, I would really appreciate your feedback, because when I get your feedback, that makes me a better talker, and then you guys get a better talk, right? We all win. It's good stuff. So please go out there and check that out. Thank you so much.